What's up, guys? We just finished checking superheat on this evaporator using the Testo Smart Probes, and we went through just a bit of a tip on TX valve adjustment and how to remember what is increasing and what is decreasing the superheat. This video is brought to you by Harago.com, a trades-only platform helping you find the right job or the right candidate. Harago.com, best in trade. Okay, so when this was installed, this evaporator, it was measured at 12 degrees superheat. We're going to do a superheat comparison today. This is about 2 years later after installation. Now, this evaporator here is used in conjunction with that first evaporator over there. There's two condensing units on the roof. There's two evaporators per. So there's this one, and then there's the one behind me. What we got to do is we got to check the superheat on each evaporator separately. If we check at the suction line at the unit, we're not going to know what the performance is of each evap. So how do we maintain superheat in the evaporator? Well, we do it with the TX valve. Liquid enters, okay, we flash that liquid off into a liquid vapor mixture. Right here, it enters through the distribution lines, goes into the evaporator. This is your equalization line, okay, and this is the capillary line that goes to the sensing valve mounted to the suction line. So there's a stem in here, and I'm going to take this cap off and show you guys the stem. Okay, so I'm going to give you guys a tip here that I learned a long time ago. Makes it easy to remember. When you increase the spring tension by going clockwise, you increase the superheat. When you decrease the spring tension by going counterclockwise, you decrease the superheat. So when we increase the spring tension, we're increasing superheat. That means we're allowing less flow through here. All right? When we decrease the spring tension and decrease the superheat, we're allowing more flow through here. Let's pretend for a minute that this machine, both evap's all tied in together, it's charged correctly and it's running properly. If we have too much superheat here, it wouldn't be running properly if we had too much superheat, but let's pretend it's charged correctly and there's nothing else wrong. Okay? If we have too much superheat in this evap, that means we're underfeeding refrigerant to the evaporator. If we're underfeeding refrigerant, we're not going to get the net refrigeration effect that the evaporator is capable of doing. If we have not enough superheat, we have chance of sending liquid back to the compressor. So that's why it's vital to check and make sure, and we're going to do that right now. Okay, this is the fun part. We have the probes on. We got the pressure probe here on the header of the suction pipe coming out of the evaporator, and we also have our temp clamp on the suction pipe going perpendicular to the header here. Now we got the Smart Probes app all fired up, and we can see our pressure. We can see our saturated temperature of the refrigerant, which is 404A. We can see our actual line temp, and we can see our superheat, 12.2, 12.3. And as we said in the beginning of the video, we had 12 degrees superheat on startup. We didn't install this unit, somebody else did, but they were kind enough to write this down. And we've just verified that we're still performing at that same level. So this TX valve is performing the exact same way it was on startup. That's it, guys. Happy HVACing.